Here we are. Okay. Well, let us get started. Okay, so today we're going to deal with arrays, which is something that's both in both Java and C have arrays, but an array in Java is an object. It's a strange object because it doesn't really have an obvious class definition, and its type is sort of modeled on the type that you get from C. So there's a lot of congruence between. They kept the syntax, and the only real field variables for an array are length. It's the length of the array, but an array in C is just an array. It's just a sequence of memory cells next to each other, and it's just a syntax for, instead of having to declare lots of local variables, you can sort of have lots of local variables next to each other all at once, and you sort of know where they are in memory, so it's efficiently do that. So it's an efficient way to do that. So let's see how to declare an array of type int. Well, let's see what we do. Let's see if we get it right. Numbers, let's see if this is right. Return. Okay, and we will save as this. And so it doesn't like putting the type here, right? So so that's one, sometimes you will specify that, but the way you declare an array is to do this, is to put, this declares an array, even though the type is, let's see if this works, right? So that's okay. So the issue is that this actually allocates memory. It actually allocates 3 slots. And if you compare that with Java, I think you do, don't you do something like, maybe I've forgotten my Java, int, you do something like int numbers equals new int 3, something like that.
Yep, that's exactly it.
So the issue is, you see, if you compare the two, this is the type. You can specify if we needed to specify a type, like in a header to a function, this would be appropriate. But so you want to remember the you want to, it's sort of a combination. Java sort of takes apart the name, which, if you notice here, it's a reference in Java, right? Well, so in Java, the name array is a reference, which means it will be implemented with a pointer, a variable that holds an address. And that's true because this creates a new object, even though the syntax isn't like the usual form of a name with a parenthesis, like a constructor. But this one sort of combines the pieces, and numbers is still an address. And so this is what happens with that. And it turns out that 3 is not a valid address. It can only be used in declarations. but we can set values like numbers square bracket 0, because the index here that you use to access the names is the offset, the distance from the address number. So numbers is an address, and this one will put a number, say 15 in the first slot. This will put one in the second slot. And this one puts one in the third slot. Okay, even though the indices are 0, 1, and 2, right? There's 3 elements, and the indices go from 0 to 2, the valid indices, so 3 is not a valid index. And the array itself doesn't know about the 3. It's just you had to know it to declare that it was of size 3. But the array itself in Java, if you could do numbers.length and get the 3 back out, right? You can't do that in C. So the question is, what does the activation record look like? Let me do something here. Let me put in int a equals 1. And int b equals 2. Now, which of these variables in memory in the activation record, A or B, is going to be closest to 0? It'd be closest to this first one. Is numbers square bracket 0 going to? It's a memory cell in the activation frame. Is it going to be close to A or B? What do you think? Raise your hand if you think it's A. No one thinks it's A? Okay, then raise your hand if you think it's B. What? And there's on Zoom?
No, like how you estimate.
Well, the issue, what do you think? In other words, there's 2 ways to do it, right? You have number 0, numbers 1, and number 2. Either number 0 could be, it's sort of, you think of it as first, right? So it could be high memory, then you go to low memory, and then low. So it could be that as you go to smaller memory cells, you go from number square bracket 0 to 1 to 2. However, I told you that the index was the offset from the memory cell.
Mm-hmm.
So what does that indicate?
That indicates that the memory goes further down. So are you looking for where the pointer to numbers
Yeah,
is
so
gonna
which
be?
one is going to be lowest in memory? Numbers of 0 or numbers of 2?
Numbers of 2.
Well, because you mean you can add 2 to 0, you can add 2 to the address of numbers and get the address of 2?
Yeah, that's gonna be my answer.
Because that means that numbers is smaller in address, right? Has a smaller address. That means it's going to be higher in the stack, in the activation frame, right?
Yes.
Okay, well, if this is lowest in the activation frame, then which one of these variables is going to be close to numbers square bracket 0? B, right? Because here's the let's draw the activation
Yes.
record for this. Do you see, are you getting what I'm talking about here, maybe? Okay, so let's draw an activation frame. How many for this? How many, oh, we're gonna need, let me,
5.
yeah, because we're gonna need no parameters. We're gonna need 1, 2, 3, 4, 5 local variables after the 3 in the, so we're gonna need 1, 2, 3, 4, 5, 1, 2, 3, maybe if I get that right, okay? And then let me see if I can then not take too much time to make these horizontal. I just need a little button here in the menu to say activation frame rather than square, right?
Mhm.
Now that was not. You see, so I have 1, 2, 3, 4, 5, 1. Well, we don't care about the activation frame so much. Okay, I mean
You
about
can
the.
probably save this as an empty
Yeah, we don't
template.
care about the bookkeeping, right? This is the bookkeeping. Not bookbinding, bookkeeping. Okay, so this is going to be the lowest variable. This is probably going to be A. We don't know for sure. This is because we don't know what the compiler is actually going to do, but I'm just saying this one, if this one was the lowest one, and then you had the numbers of 3, right? Probably the problem is that I'm not setting this to anything, so it may be that this is spurious. And then you'd have here would be numbers would be this address here, and this would be numbers plus. This is numbers plus 0. Numbers no, but you see it's here. Up here I want numbers plus 0, numbers plus 1. And numbers plus 2, because these are low addresses and these are high. So whatever address this is, if I add 0 to it, I stay there. If I add 1 to it, I get there. If I add 1 to this numbers address, I get there, right? So, so this is where numbers is, right? Let's take this away to emphasize that numbers is the address of this slot here, and you have to add 0 to get there, 1 to get there, 2 to get there. So we have B up there. Now it could be that I'm since I'm not allocating anything here. So what I could do to sort of, let's see if I can. Oh, this might confuse the issue. Let's put this over here. So we put numbers in the spaces before B, and then we can compile this and see, check. Oh, I don't want this. I don't want this one. I want this one. Open makefile. It's getting a little bit long. There it is. And we want arrays 1. Save, we do make, and it says, what have I done? Let's see. It says there's something illegal. Well, it may, oh, I see the problem. It doesn't like, I think, putting an assignment before it wants all the declarations up top. There you are. Or there we are. Okay, then we can open arrays 1, arrays1.asm, and see something. Let's make this. The first, you see, we expect 5 local variables, and there they are. 5 local variables, so that means that's signed. Okay, so then we expect this first one here, this first triplet here, 3 to be, well, R4, 5 should be the 1. Here's, R4, here's R4, R4 plus 1, 2, 3, 4, 5. Yeah, so here's R4 plus 5, which is the 1. that just confirms that this first triple here is carrying out the int a equals 1. Okay, and then let's look at there's 4, then there's 2, 1, and 0. So it looks like it looks like it's doing A and B first, right? So let's look and make sure R4 plus 4, 1, 2, 3, 4 is 2 plus 4. So this is int B equals 2. And then you have the indices of -2 with R4 crosshatch 3 is 15, right? Is 15. So this first one here is the number 0 equals 15. And this one is going to be numbers 1 equals 25. And this will be numbers 2 equals 35. Because the point is that the whatever the address is of R5, this R5 minus 2 is lower than R5 minus 1. So if I add 1 to R5 minus 2, I get R5 minus 1. If I add 2 to R5 minus 2, I'm going to get R5 minus 0. So it matches the order of doing index arithmetic. If I add 1 to this index, I get so this is a shorthand. The point is, this is a shorthand for numbers plus 0. If what I've told you is true, this should be true, right? We should in principle be able to get there. And let's see if that works. Okay, what I'm going to do is I'm going to comment out these 3 lines and then substitute for them. Well, if we want to put something into numbers plus 0, we can't. That's the address, right? So in C, we want to say we want to put something in. The address is numbers plus 0, so we want to put something in there. We would say this equals 15, and then numbers plus 1 equals 25. Numbers plus 2 equals 35. And we could then save as array. I'm going to call it, I've got some other arrays files, so I'm going to call it arrays P for pointers. Okay, let's see if change the make file. Let's see if this works. And it doesn't have any errors, right? So it seems to like it. And then we can open the arrays PASM. And what we want to do is we want to compare it. Let's see if we can line it up. There's the 5. Okay. There's the A. There's probably the int B. Okay. R5 minus R4 plus 3. Okay, and so it's identical, and you can see that the numbers here, 1, 2, 15 are the same. So that in fact, these two programs, one with this and one with this, do exactly the same thing. They are the same thing. This notation up here is just a syntactic convenience because you have to type less, and this is just a convenience notation for the programmer. What's really going on underneath is this address arithmetic. But of course, the address arithmetic is, again, just for the compiler's point of view. In some sense, there's no arrays in assembly language. It's just, you're just coercing a certain pattern of memory usage in the activation frame. That's all that's happening. There's no arrays in the assembly language. It's just, you just happen to have lined up these three memory cells. They're next to each other, which presumably makes it easy to go from one to the other because they're close by. Okay. So that is how you declare an array and how you assign values to it in two different ways. Okay. And then if you wanted to say sum up the values, right? We could do int I equals 0, and then have for I, well, we can just not make it so redundant, although I equals 0, I less than or equal to, well, less than 3, right? Because we want it, 3 is not a valid index, so we want I to go over the valid indices of the array, so that's why it's got to be less than. You're probably aware of this when you do a for loop over an array in Java. You put a less than, then you do like let I less than numbers dot length. You'd have to keep it in bound, then I plus plus. And we'd also need a variable if we wanted to sum them up, right? We'd have to have int sum equals 0, and then sum equals sum plus numbers square bracket I. Presumably you could do the same thing. We could put one of these in, right? This could be sum 1, and this could be sum 2. One. And then this would be sum 2 equals sum 2 plus star numbers plus I. All right? Because over here, this is just saying, well, I take the number and I put it into the memory cell pointed to by the address numbers plus 0, 1, or 2. And over here, it says, oh, I go and I retrieve the number that's in the memory cell numbers plus I for the various values in the loop. So this one goes to the memory cell and does a load, right? In LC3 assembly language. And this one uses the same address with a store. So let's see if this works. Who knows? We'll see. Let's see, this is array. I've changed arrays P, so let's see if it still compiles. It didn't like, oh, I know what it is. Again, it doesn't like me declaring all these variables inside, so I have to put them up at the top. In a regular C program, you don't have to, you wouldn't have to do this. You can interlace them. That was a lot of errors. And then let's now open ASMP. Reload, yes. Okay, so now we have an activation record with 8 local variables, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8. And we've got 6, 7, 4, 5, 3, 2, 1, 0. And this is probably the beginning of the for loop, right? So we just to make sure, because the indices here are scattered all over the place. We want, this is R4, and we want R4. Well, where are the oh, there's the 3 for the 3 there. Oh, this, which one is this? This is the start of the array. So this is R4 plus 1, 2, 3, 4, 5, 6. Plus 6. Okay, then the first one, 1, 6, 7, 8, 9. R4 plus 9 is the 1. R4 plus 8 is the 2. You notice, let me see, let's look at these numbers. 1, 3, 2, but the 3 is up here at this is different, but the 1, 2, then the 0 comes here, right? Okay, so, but the 9 here was the 1, so this is clearly int a equals 1, but this is 7, right? That's the 0. So this is a 0. Well, which one is this? Int, well, no, it's 8, right? 8, what is 8? 8 is the 2. So this is b equals 2. And then I've got 2 7s. So probably this is int sum 1 equals 0. And this is int sum 2 equals 0. So you notice that the local variables, a, b, I is not assigned, so it's ignored. A, B, 1, A, B, 1, 2 is an order, A, B, so that the order of these in the active, you can, however, they're not in the activation frame. Like if I drew the activation frame, it would be sum 1, then sum 2 above it, right? Then A, then B. So if I drew the activation frame, it wouldn't be, A is not the lowest one. So like, I think there was a question on the concept check that usually without, if you just put in variables, our default thing on a test is that we're going to take it as if these variables are from lowest to highest. Otherwise, it's chaotic, right? So so if we just have like 4 variables, A, B, C, D, A is lowest, then B is highest, then C, then D, moving up the stack, and so to lower memory cells. So that's what I mean by usually, is that if you don't do something fancy like this with arrays or functions or pointers, or it reorganizes it like that. Okay, well, so we've got all of this stuff done, but now we have to assign the values. Well, this is 654. 654 is the this is the int. Well, this is setting numbers square bracket 0. Then number square bracket 1. Number square bracket 2. Right? That's where I'm setting these values. even though I'm doing it with this notation. This is the 15. Okay, so you've got all the assignments, and this is the for loop, right? And if you remember the for loop, it's getting, let's see, have we done, how about I, right? Like here, there's a R5, 2, 3, 4, 5, 6, 7. So that leaves R5 was declared with int I, right? So R5 plus 0 is I, is the loop variable. So it loads so that R7 here equals I, which here is going to be oh, well, I haven't done this, right? This is the I equals 0. That's the start of the for loop, but we've done the I equals 0. Then we have to check the I less than 3, right? And so if we come down here, we're going to oh yes, the thing is this: we want to sort of see the structure of what we are doing, because in fact it's not clear. Let's see where there's branches. There's a branch down here. There's a B, R, and Z, and there is a J, M, P, R7. So this branch L15 is returning. This is the starting of the return, right? Because you can recognize that from the R5 plus 3, and the return value is 35. I'm not sure why I put 35 there, but that's going to be hopefully that's R4 plus 4, 1, 0, 1, 2, 3, 4. Yeah, so this is the starts return here, right? So this is the jump out loop. So because I put a 3 in here, and this was 0, I think it just assumed that everything was okay. Because let's go and see what it actually does. This is like a different implementation of a for loop, perhaps. What is R3 here? R3 equals R5 minus 3. R5 minus 3 is you see R5 equals numbers, right? So that's numbers minus 3. So that's the address numbers minus 3 that it's not loading, it's adding. This is, what is R7? R7 equals R7 is I, right? So this is this is, this is not quite right. This is R5 minus 3, which equals numbers, right? R5 minus 3 is the number's address. Yes, numbers. So R7 here is I. So R7 now equals numbers plus I, where I starts off being R4 plus 7 is 0. Starts at 0. So that's what you expect, right? It's doing numbers. It's actually got numbers plus I. Then it's going to load R5 minus 4. Well, what's R5 minus 4? Well, R5 minus 4 is sum 1. So this is R3 equals sum equals what's in sum 1, right? So it's going to equal sum 1, which equals 0. And then this, oh no, it's yes, it's the address. It's not the 0, it's the, okay, and then this one is R7, no, let me see, let me go be more careful. R5 minus 4 is the address of sum 1. This is loading, so R3 equals what's in sum 1, which equals 0, right? Then this one is R2 equals what's in R7. What's in R7 is numbers. Oh, so R7 is what's in numbers square bracket I. So what this is getting, R2 is getting is what's in numbers plus I, right? Which equals the 15. So R2 is down to 15 because it's getting what's in numbers plus I, with I is 0, right? Are you guys following this, or is it, okay? Then here it's adding R3 and R2. So R3 is 0. So this is R3 equals sum 1 plus star numbers plus 0 here, but it's going to be I in general, which equals 15. So that's our running sum. Now that has done this first line here, right? But it has a second one to do. So R5 minus 4, let's see. Oh, no, I haven't stored it. This last one does the storing. This one does mem address of sum 1 equals 15. So that gets the final. Then I'm going to start with R3 equals. Now, if we're going to compare this code with this code, because that's R5 minus 5 minus 5 is, let's see, is sum 2. This so R 5 minus 5. Let me see if did I get that right? Sum 1 is R5 minus 4. R5 minus, where's the, oh, here's
minus 5.
Here's the R5, here's the R5 minus 4. This is the R5 minus 5, which equals, since I'm loading, that's what's in sum 2, which also equals 0. Let me just put, it's the analog of this line here, right? Then here we're loading R7 equals, what's in R7? Well, R7 is still, this is still doing numbers plus I, because that's still R7, right? Which equals 15. Then this is R7 equals R3, which equals sum 2 plus star numbers plus I, which equals 15. Then it's storing this back. See, this is 4 and 4. This is 5 and 5. So this is mem address of sum 2 equals 15. So we've completed these. We've completed the body of the loop, right? And then this stuff here. So it's gone through and it's done it doesn't, like before we did a for loop, it had to check this if, right? But the compiler saw, oh, I is 0. We know what the 3 is, right? So it didn't have to do the check at the top. It just went ahead and did the first iteration of the body as if this is more like a do loop or something. Okay, then it's going to, but now it has to check because we have to increment I and then check when we've gotten to, so that R50, I think, is, R5 plus 0 or minus, this is minus 0 is I. So this is R7 equals I, which equals 0 at first. Then it adds R3 equals, oh, this is R3 equals address of address of 1, right? Address of 1. Then R3 equals 1. And here R7 equals R7, which is I, plus R3, which is 1. Then this is mem of address of I equals I plus 1. Okay, so these 4 lines do the I plus plus. This is all I plus plus done. Okay, then it's going to go and check, because it did the I equals 0, now I is 1, now it has to check this, and I'm assuming because we're out of time, that this is, and you can see here's the -1. This stuff here is going to implement is I less than 3. If it's not true, right, if you get that this is 0 or negative, that means that this is going over the top and you jump out of the loop. So as long as you haven't jumped out of the loop, you don't branch, you fall through here, get this address and jump to R7. So that's going to be wherever the address is of R4 plus 0, which is the L10. This is start of body of loop. Okay. So the point of all this is the for loop has a little wrinkle in the sense that the compiler does an optimization. It doesn't have to check this first. And what it does, so it doesn't have to like jump into it's going to put this at the end anyway, but it doesn't have to jump in and make a decision because it's already decided. The compiler decides. If it can do arithmetic, it does it for you. But then these 2 things, it does exactly the same thing to provide, so that the calculation it does is exactly the same with the 2 forms of the loop. Okay, that is all. We're out of time. And we'll continue with this on Wednesday. Because we have arrays and structs. And we'll finish up with arrays, do character arrays and strings on Wednesday, and then start with structs. And
Professor, do you quickly mind if I ask a clarifying question about where parameters are stored in the activation record?
okay,
I got
yeah.
a little confused about that this weekend.
Okay, so here is, let's say that I have a function int f, feel free to head off. This is just an answer to a question. Int b, int c equals 1, int d equals 2. Just let's give them a different number. Int e equals 3. And we want to do an activation record for this setup, right? So what we have is, try to freehand this, we have 2 parameters at the bottom. So the first thing are the parameters, reading from this end. So it'll be B, then A, read from the end here inwards. Then in the usually, well, we'll for sure have the 3 bookkeeping, right? This is return value, return address, and saved R5. Then we start with R5 is going to point here, which is going to be this first one, C, then D, then E, and R6 will point here to the top of the stack. So there's your 3 local variables. There's your R5, and here's your 2 parameters. So if you want to access the first local parameter, you do, so A is obtained by R5 1, 2, 3, 4 plus 4, and B by R5 plus 5.
So if I'm understanding correctly, when the function is called,
This is set up.
because I looked at the activation record, like assembling, like being built, and it doesn't show the copying of A and B. So that's why I'm confused. Is like, where
yeah,
is it?
because okay, the thing is this, main does this.
Main copies it into the next 2, and then the function is called, and the activation record is built.
Yeah. The problem is when you call the function, when you call f of 2, 1, right, for A and B, only main knows about the 2 and the 1. The function doesn't know about the 2 and the 1, right? It doesn't know where these values came from in main. They could come from anywhere. They could be any variables. Like I could do f of s and t, where s and t could be anywhere in main. So only main knows what values should be in the.
Ah, gotcha.
So main has to write the parameters, but then
okay.
And then everything else is written by the function. So this main does just the parameters. Then the f does all that does the rest.
Gotcha. Thank you so much. I was confused about that this week and during the quiz.
Okay, well, we'll have another cop version of the quiz when you will ace all those things. Okay, this is.
Thank you. I'll be back.
This is April 29th. There. Okay. So I can get rid of that, and I can, and we're going to go to